Okay, so this is a problem-solving question. What we need to do is we need to sort of unpack this paragraph and sort of understand the problem a little better. So we have a tennis ball tossed upwards from a balcony. The height of the ball in feet is going to be expressed by this model where x is the time in seconds. So we've got a y value and we've got an x value. What does the y value stand for? D. The height. So this is the height of the ball. What does the x value stand for, Eric?
Time, seconds.
This is the time. So we need to consider that sort of the domain and range a little bit. So with the x values, what's the smallest possible x value we can have? What's the smallest possible x value?
0.
0. Why? Because time starts at 0. We can't really have a model that describes the height of the ball and start talking about where the ball was. It's not going to make any sense. What about the y value? What's the minimum y value we can have?
Also 0.
Why?
Because it can't start in the air.
It can start in the x, we're on a balcony. But why does the height have to, the minimum have to be 0?
Because that's where you measure it from.
Because that's the ground.
So if a negative value would mean what?
Underground.
There is no. If it was
Underground. It means the ball has gone underground. Because the height above the ground has to be positive. Otherwise, you're not above the ground. You're under it. So the y value has to be greater or equal to 0. So this means we're going to need to draw a graph that looks like that, with time in this direction and height in this direction. So we take our graphing calculator, press Control Add Page, follow along, and we add a graph. So with this graph, we don't have to expand this into standard form.
So how did you get the graph?
So when you're on this page, Control Add Page to graph. So we can type the function in as we see it here. The graph looks like this, and it looks nothing like the graph I've drawn here. So I need to adjust the window settings. One of the hardest things with the calculator is understanding the window settings. You want to sort of, we know that it's going to start at 0. If we look at the graph, it reaches 0 again, here somewhere between 1 and 2. So in this direction, we only need to go from 0 to 2. If we look at the height, it starts at the top and here at 6. Now that's too small a value, so let's go something bigger. This one could be trial and error guesswork, or you can there are some techniques you can use to find the value that needs to be higher. But let's go from 0 to 20 in this direction.
Sorry. Is there a way to find out where the graph reaches the y-axis and the x-axis?
Yeah, we covered that last week. So you go onto the calculator page, you press functions, this is F2. So if you find the y-intercept, you know the y-intercept is going to be 12.
How?
So,
Why is it F2?
So the function that we just entered it in as, when I typed it, says F2.
Yeah.
Because I've used my calculator earlier today, and I've already made an F1. It was the same function with the class I just had. So that's why you were F2, and they were F1.
Okay, then why is it 0? Why do you put 0?
Because the y-intercept occurs when x equals 0.
Oh.
So if I go on to this page and I pull up one of the functions and I say x equals 1, it will say 12. If I say, x equals 0.5, it will give me another value, 16.
Okay, how about for
If
the
I say x equals 0, it will give me another value.
How about for the x value? You want to say where the graph?
We talked about that one also previously. You need to find an x value, you need to use the nsolve function. So menu, algebra, nsolve. You pull up the function, you put in an x value and you say this is equal to some value. And then say solve for x. This will give you the first solution. And it says x is minus 0.3. Doesn't make much sense. You can maybe find another solution if you tell it to look in the positive domain between 0 and 2. It'll give you another solution. That's more complex. Okay, so we've got our graph drawn here. We need to press menu, window, window settings. We want to go from 0 to 2. We want the y values to go from 0 to 20. And then it will draw the graph for us, and it will look like this. Here is the graph. This describes the ball's height going up and then down. The question, find the maximum height of the ball. Where on the graph will we find this information? Anthony? At the highest point. So we need to find the vertex. We need to find the vertex. If you remember the procedure for this, we press menu, analyze graph, maximum. Scroll either side of the graph, and it gives us a coordinate, 0.5, 16. Which of those two numbers describes the maximum height of the graph? Is it the x value or the y value? Is it the x value or the y value? The y value. Because the y describes height, x describes time. Find the maximum height of the ball. So max height equals 16 when time equals. So it says, what is the time taken to reach this height?
0.5.
0.5. So this is feet, and this is seconds. Lastly, there's one more question. Determine how long it takes for the ball to hit the ground. How long it takes for the ball to hit the ground. Where do we find that on the graph? Where do we find that on the graph? When it hits the ground, how high is it? 0. So we need to find the zeros. Menu, analyze graph, 0. We click either side. Window. And we get the 0. So it hits the ground. At 1.5 seconds. Do one more. Do we have internet back?
Yeah.
No.